Stoichiometry Practice Worksheet 2, Part 1. Calculate the mass of 1.58 moles of methane. So what's our given here? Well, our given's the only number that is actually, given, which is 1.58 moles of methane. First thing I want to do is write out my given, 1.58 moles of methane, CH4. I'm going to put a multiplication sign and a line. Whatever unit I start with is going to go on the bottom, moles of methane. And what I want here is the mass, and we know that mass is represented by grams. If I find the gram formula mass of CH4, it is 16. So there is 16 grams of CH4 in 1 mole of methane. I want to make sure that my units cancel, so moles cancel moles. They should always cancel down and to the right. And if I work this problem out, it'll be 1.58 times 16 divided by 1, which will give me an answer of roughly 25.3 grams of methane. Now, one thing that I want to pay attention to here is number of significant figures. I can look at my given, the 1.58, and see that there are 3 significant figures here, which means my ending answer should also have 3 significant figures, which I do see right here. The 2, the 5, and the 3 are all significant, so I have 3 significant figures here. Remember that these numbers right here, as part of the conversion, is known as an exact number, and we don't take these into account when we're trying to figure out significant figures at the end of our problem. Let's look at the next problem. How many molecules are there in a 0.00583 mole sample of water? I want to write down my given first. 0.00583 moles of water. Now, remember, multiplication sign and a line. If you see the word molecules or ions or atoms or formula units, you should be thinking of Avogadro's number. I know that 1 mole of anything, and in this case, it's water, moles of water, that's equal to 6.02 times 10 to the 23rd molecules of water. Molecules, we'll write the whole thing out. Molecules of water, just to stretch that out. Let's make sure that our units cancel. Moles cancel moles. So I'm going to put into my calculator 0.00583 times 6.02 times 10 to the 23rd. And when I get an answer here, my answer should be 3.52 times 10 to the 21st molecules of water, H2O. Let's look at our next problem. How many molecules, so we're looking at molecules again, are in a 35 gram sample of water? Now, we'll notice here that we're not doing this in a single step. We can't go directly from grams to molecules, but the first thing I'm always going to do is write down my given. So 35.0, which means I'm starting with 3 significant figures, grams of H2O. Now I'm going to follow the AP Chemistry mantra here and convert to moles. Always, when in doubt, convert to moles. So 18 grams of water is my gram formula mass, and that is equal to 1 mole of water, 1 mole H2O. Multiplication sign and a line. I know that in 1 mole of water, there are 6.02 times 10 to the 23rd molecules. And the big thing here is being organized and labeling. If I'm organized and I label, then I can cancel my units and make sure that I have this set up correctly before I put all these numbers into my calculator. Grams cancel grams, moles cancel moles. I'm left with what I should have labeled as molecules right here. So if I work this out, 35 times 1 times 6.02 times 10 to the 23rd, and divide that by 18, I should get 1.17 times 10 to the 24th molecules of water, H2O. Key thing here again, when you see molecules by itself, atoms, ions, formula units, that's when you're going to use 6.02 times 10 to the 23rd. Let's look at our next problem. Calculate the mass of 2.19 moles of CH4. So my given is 2.19 moles of methane, CH4, multiplication sign and a line. I know that 1 mole of methane, CH4, is equal to the gram formula mass of methane, which is 16 grams CH4. I'm going to cross out my units to make sure I've set this up correctly. Moles cancel moles. So 2.19 times 16 gives me 35.0 grams of methane. Again, here you want to be looking at significant figures. 2.19 is 3 significant figures. 35.1 is 3 significant figures. It's the right answer.